So now that we have gone over multiplying polynomials, we're going to take a special look at some special cases. So when we are multiplying binomials, there's three special cases that we're going to talk about. Remember, a binomial just means that it has two terms in our polynomial. And we're going to be looking at when we have two terms added together and that grouping is squared, what does that special case look like? So when we do that, obviously we're going to use the box method, but every single time we multiply that through, we're going to get a polynomial that looks like a squared plus 2 times the value of a and the value of b plus b squared. So the reason why it's called a perfect square trinomial is because trinomial has 3 terms, and it's called a perfect square trinomial because we're squaring that first term and that second term that was originally in our binomial. So moving on, we have also a perfect square trinomial where there's a difference. So instead of having add, we have minus. And when that happens, it's almost exactly the same, but our pattern looks different because of the difference. So instead of plus 2ab, we're going to have minus 2ab. If it's got a minus sign, we're still going to have plus b squared. So the only thing that changes between those two is if it's a sum, we're going to have an add sign in front of that second term. And if it's a difference, we're going to have a minus sign in front of that second term. So those are both two different types of perfect square trinomials, where we just have a plus for both of our factors, or we have a minus for both of our factors. The other term is difference of squares. So this is where we have the same term first and second both times, but this time we have an add and a subtract. So we're mixing up our operations there. So when we do that, what ends up happening is we get a polynomial that looks like a squared plus b squared. Sorry, not plus, minus b squared. So it's called the difference of two squares because obviously our final answer has a difference in it, and it is made up of the first term squared and the second term squared. So the reason why that happens on that one is because if we were to multiply that out, and you guys don't have to copy this down, I'm just showing you guys what this would look like. So if we said a and positive b and a and minus b as our two factors, when I multiply that out, I would get a squared in the first box, minus ab in the second, ab in the third, and minus b squared in the second. And when we do this special case, these two end up canceling out because they're opposites of each other. So the only thing that's left is that a squared and that minus b squared. So that's why this one doesn't have a middle number, because the fact that we have the plus and minus makes that middle term cancel out. So those are our special cases. We're going to do an example of each one, and then you guys are going to go ahead and try. So on our first example, we could go ahead and multiply this out and use the box method by saying x times x gives me x squared, x times 6 gives me 6x, 6 times x also gives me 6x, and then 6 times 6 gives me 36. And then we can go ahead and simplify, and we would get x squared, and then 6 plus 6 gives me 12 x's, and then plus that 36. So this is our final answer. And we can always do that multiplication out in our box method, or if you like the FOIL method better, or whatever is your favorite method. But because it is a special product, we've got the same factor multiplied twice, we can go ahead and use our shortcut that we looked at on the front. So for our addition, it's going to be the first term squared plus 2 times the first term times the second term plus that second term squared. So it would be x squared, and then 2 times x times 6 gives me 12x, and then 6 squared is 36. So either way you do it, you would still get the exact same answer, whether you multiply it out using one of your favorite methods, or if you know that it's a special product and you can go ahead and use this shortcut to get to the answer. Looking at one where we have a difference in both, again, we can go ahead and use our box method or whatever our favorite multiplication method is. And in that first box, x times x gives me x squared. Second box, x times -4. Third box, -4 times x. And in that last box, -4 times -4 gives me positive 16. And again, I can go ahead and combine like terms. And I would get x squared minus 8x plus 16. So that's multiplying it out the normal way. But like I said before, you can also know that that's a special case. We have a difference in there, so it's going to be our first term squared, and then minus 2 times our first term times second term, and then plus our second term squared. And then again, when we simplify, -2 times x times 4 is -8x. 4 squared is 16. So either way, whether you multiply it out using your favorite method or know your special product shortcut, you get the same answer. And then last but not least, again, same thing with this one. We can go ahead and use the box method and multiply that out. And this is our difference of squares. So we're going to have 1 plus and 1 minus. So x times x is x squared. -2 times x and 2 times x, and then we have 2 times -2, which is -4. And then again, because this is difference of squares, 2x minus 2x cancels out, so we're only left with our first term squared and our last term squared. So we can multiply it out like we just did, or same as before, I can go ahead and use my special case rules and say that the difference of squares is going to be the first term squared minus the second term squared, which would end up giving me x squared minus 4. So either way, whichever method you use, the shortcut or the multiplication method, you get the same one each time. So go ahead and do the you try problems, and we will check back in tomorrow.